Eric Burgess here, and we are told to find the 6 trig functions, and we're told some information. We're told that cosecant of theta is 2, and theta is in quadrant 2. Alright, so let's just think about this. So we're going to have a quadrant 2 hanging around here, and there's going to be some angle. I'm just going to sketch a 45. It's probably not a 45, but whatever. And we're told that, this is where our angle is. It's in quadrant 2. And we're told that cosecant theta is equal to 2. Now, I want to remind you that we could write a 1 under that 2, and it would still be the same thing. So we could have cosecant theta is equal to 2 over 1, right? So it's the same thing as equal to 2, because 2 over 1 is 2. So now remember that cosecant, right? This is the reciprocal of sine. So sine is y over r. So cosecant is r over y. And what does that tell us? Well, that tells us that this 2 is r and this 1 is y. And this is great news because we can fill that in. So now we could say, okay, if we were to drop a perpendicular, let's just pick a point and call it 2. So we're going to call this distance from here to here 2. And this distance from the right here to here, we're going to call that 1. I wrote 1 is 1. That's a y. So knowing this, we can find the last spot. Now I know it's a special triangle, but for the life of me, I can't remember it. So knowing this, we can evaluate the last spot, just the Pythagorean theorem. So we have 1 squared plus, and we're going to call this x. X squared is equal to 2 squared. And so we're going to get x squared, and then this is going to evaluate to 4, and we're going to subtract 1. So we're going to get 3. So x is equal to the square root of 3. So we can replace this x here with the square root of 3. Now, knowing this, we can go ahead and evaluate all our trig functions, right? Because our angle would come around like this and hit here. And so we would have sine of theta is equal to, and now sine of theta, well, we're already told cosecant, so sine's kind of given to us. Sine is the reciprocal of this, so we would expect 1 over 2. And if we look at that, that's exactly what we get. We get 1, and then over the hypotenuse, so we get 1 over 2. You can think of it as opposite over hypotenuse, or y over r, whichever one floats your boat. So we get 1 over 2. We already know cosecant theta is equal to 2. Now we can find cosine theta. Cosine theta is adjacent, which is rad 3, over hypotenuse, which is 2. And the reciprocal of that is secant theta, which is going to be 2 over rad 3, which is equivalent to 2 rad 3 over 3, right, if we rationalize this denominator. And then we have, finally, tangent of theta. Looking at our triangle, tangent of theta is opposite over adjacent. So opposite adjacent. So we're going to have 1 over the square root of 3, which when we rationalize is going to be rad 3 over 3. And then we're going to take the cotangent, which will be the reciprocal of this, cotangent of theta, which will be rad 3 over 1. I'm going to use this one for the reciprocal, which will just end up being this, which is just rad 3. And so these would be our answers. And we get all that information from the fact that we're told what quadrant we're in and what it's equal to. Now, I might be going, why do we need to be told the quadrant? Well, the quadrant's important because there's actually 2 places where cosecant can actually equal 2, right? There's also, when we go this way, we also get a positive measure of cosecant. And so for that reason, we have to be told what quadrant we're in, and that allows us to deduce what these other values are. And I just realized I made a critical mistake here. Because we know that we're going this direction, we know that this rad 3 is negative. So that means that wherever we have a rad 3 in these, they're all going to be negative. So this is going to be negative. This one's going to be negative. This one's going to be negative. This is negative. This is negative. Because the only thing that's positive here, well, first, the main reason is because we moved in the negative x direction. But you can also remember all students take calculus. And so only sine and cosecant are positive in quad 2. So that means that these other 4, these guys, have all got to be negative. So we got negative, negative. I should put a negative here and a negative here. So, yep, that's another thing that easy mistake to make. So be careful when you do that, because when you solve the Pythagorean theorem, these squares obscure the negatives. So you have to be paying real close attention, because right here we'd say, well, there's a plus or minus. We're taking the negative case for down here. And the reason is we're taking the negative case because we're in quadrant 2. And that would be why we pick the negative case. When it's R, it's always positive. But when it's X or Y, you've got to be paying attention to where you're at. So if you have any other questions about this, let me know. Subscribe and hit that bell icon for future videos. And we'll catch you in the next problem.